Hi everyone, my name is Random Sharma, and this is my Milestone 4 demonstration and reflection for the software architecture course. My project is called CellarPro, and it's a wine cellar management application. The purpose of CellarPro is to help wine enthusiasts, collectors, or restaurants keep track of their wine inventory, get food pairing choices, organize their bottles, and export reports. The audience includes anyone who can maintain a wine collection and wants smarter tools for classifications, recommendations, and cellar organization. CellarPro supports the full life cycle of managing a wine cellar. Users can add bottles, delete bottles, search and filter through their inventory, get live wine pairing suggestions using Spoonkiller API, automatically detect low stock items, and export the entire cellar to a CSV report. This system is backed by a Neon PostgreSQL cloud database and integrates a third-party API and uses multiple design patterns, including repository, strategy, proxy, and singleton-style DB connection. All right, without further ado, I'll start the demo. Let me start by demonstrating my first functionality test, which is inventory management and advanced search filtering. I'll run the application through the command line interface. So I have the command here, which we can run. All right. So I'll run the application through the command line interface. All right. So there we are. I already have a set of bottles added, and let's try to list them. So actually, before we do that, you're presented with like a CLI input options. You can do the following seven things, and the last one's exit. Adding a bottle, listing a bottle, deleting, showing pairing notes, showing low stock alert, which shows every bottle that's below three in terms of quantity. You can also search for bottles, and of course, you can export into CSV. All right, so I've already have a set of bottles added, so let me list them first. So if I select two, it lists the few bottles that I have in my inventory of my cellar. It starts at two because the first one was a test one, and I use the delete bottle function to do that and remove it. Actually, I can quickly do that as well. So if you went to delete bottle, and let's say if you want to remove the Whispering Angel Rosé for some reason, then you can just give it the ID. And now if we go and list the bottles, you will not see that bottle available in our inventory. Um, so by listing the bottles, you can see multiple bottles across different varietals, regions, vintages, and prices. Now I'll demonstrate the search functionality. This uses dynamic SQL Alchemy filters inside my repository. Okay. So I asked for a region filter. Let's give it a Bordeaux because I believe I do have a Bordeaux in here. So if I do that for the region, it also asks you for varietal filter. You can leave it blank or go more granular and it'll pair those qualities together. Sorry, those filters together. Give it a max price. I mean, we could say 30 and it'll still show that option, but if we say 20, then it'll say like nothing in inventory. So yeah, and same for vintage, right? So if I did that, as you can see, the option two, the Bordeaux 2018 shows up. Um, Here's the CLI passes the search request to my controller, and the controller delegates to my repository, which performs a SQL query against the Neon database and returns only the bottles from the Bordeaux region. Right here, actually, I can show that. So yeah, so controller talking to the repository, and the repository is searching um, based on the region or whatever parameter you provide. This demonstrates the requirement, the ability to search using multiple criteria. So yeah, for my second functionality, I'll show how the system integrates with the Spoonkiller Web wine pairing API. This is implemented using the proxy design pattern, which sends a request to food, wines, dishes. That's their free available option, as you can see here. Not here, actually. Here. Yeah. Spoonkeeper endpoint then normalize the varietal name and cache the result on the bottle. So we only hit the API once because I do have a limit with my free plan, and of course I don't want to go for above that limit. As you can see, I've done 6 requests today already. Yeah. So there's that. Let me select a bottle. So show pairing notes. And we're gonna look at the Neon database. Neon's pretty cool because it has this. I don't have to write a SQL query. I can just refresh this and see the values. This is the caching I was talking about. Like for example, for this Bordeaux, I did this already, so it cached. So maybe we'll do the Sonoma or something like that for our next test, or the Chardonnay, right? So let's say if we do that, bottle ID for pairing. I do have the bottle ID here, which is 4. So if I say 4, it will query and this returns a pairing suggestion based on the varietal. If the free plan API blocks a request, the proxy automatically falls back to a local pairing string. So user always sees and receives a helpful output. So Chardonnay is a dry white. Wine, which is bold and full bodied, right? So, yeah. And now if we go to our spoon killer and I refresh this, you'll see number of requests has increased to 7. And if I go to my Neon database, let me show you the caching feature. So when you refresh this, actually, I'm going to use this, but anyways. Yeah, so we did Chardonnay, so now it's cached it. So next time when we ask for a pairing for this, it will not ping spoon killer, spoonacular, spoon killer, how you want to say it, and cost us credits, right? And just pull from the database. Okay. Um, yeah, this demonstrates the third-party API integration with caching feature. Um, so I'll also quickly show the CSV export that I've built. So if you click 7, export CSV, it'll ask you for the name of the CSV. Let me just make sure I didn't already add it to the server. Okay, yeah, so I'm not using inventory, but I mean, I could give it any name. Let's just keep it simple. Uh, no, not do that. Inventory.csv. And as you can see, it created that. So now it's created a CSV based off of our database info. Next, I'll show you 2 architectural views from the 4+ view model, starting with the logical view. Here my class diagram from Milestone 3. In CellarPro, the main components are the bottle repository, the wine proxy, the 2 classes for reporting, and the CLA plus the controller, which orchestrates everything. So now let me show you how this is realized in code. So if you look at the models.py, this is the bottle ORM entity used across the system. This is the bottle repository, all CRUD operations, so the creating, reading, deleting, and updating lives here. And then the Wine API proxy, this proxy implements the Spoonacular API integration and fallback logic. And you'll see the fallback logic right here. And yeah, we picked Chardonnay, and you can see like, this fallback said roasted chicken, but of course, in our database, we're saying Chardonnay is a dry, like it's a completely different strain from the Spinaculate API. These are the strategy classes for the low stock alerts and CSV export that I'm using. This shows how the logic view directly maps to the code. Yeah, now let's look at the process view from our milestone 3. So it shows the sequence, the command line interface, goes to controller, goes to repository, and then database. And for pairing, the controller also calls the proxy. Let me show you this flow in the actual code. Um, yeah. So in the command line interface file, CLI.py, very descriptive. This is the CLI where the user chooses search. The CLI doesn't handle the logic; it just delegates to controller, as you can see right here. So create a controller object, and then it's being called depending on what they pick and the different functions on the controller. And then in the controller receives a request and forwards it to the repository, of course, and that you'll see like there's the bot repository being imported, and then it does the functions on the repo object. Um, Object, yeah. Um, yeah, and then finally in the repository, this uses the SQL Alchemy to query the Neon database. This separation of concern is exactly what the process view diagram illustrates. Yeah, so next, I will reflect on some of the work I did using the Git timeline view. So if we look at the timeline here, okay, let me just quickly show you this, where I'll just count so you have to read through that. The minimum requirement was 15 commits, and I've done 20. Um, and they're of course listed over here in the graph view. Yeah. So there were a couple of issues I I ran. One of them was I ran into the API bug. The Spinacular free plan rejected the food-wide pairing endpoint, which I thought would work, but it just declined it with a forwarded error and had to go to the food-wide dishes instead. And yeah, because of that, I had to do a bit of switching, and then I had to do some API cleanup as well, which is a bit annoying. But nevertheless. Yeah. I also added a fallback. This kind of motivated me to do that a little bit. So I just built some quick copy for this. Like things are handled more gracefully if the API fails. Another issue I encountered was the module not found error as I was working through that, and I fixed that during my initial few commits as well. For SQL Alchemy, I believe. Yeah, but yeah, it's okay. So yeah. This concludes my demonstration and reflection from Milestone 4. Through this project, I applied the 4+1 architectural viewpoint view model, implemented multiple design pattern, and created a cloud database using SQL Alchemy, and of course worked with a third-party API. Thank you for watching, and yeah, appreciate the time.